Good morning to everyone, to a lecturer, Sachin Kim, and fellow students. My team and I will be presenting to you about the Calculus 1, Mat183, application of differentiation, specifically related rates. So, for introduction for our team, we have Shabel Azam, me, Anik Hazik, then we have Muhammad Sajlian Shah. So, for introduction, what is differentiation? Differentiation is a process of finding the derivative or rate of change of a function. The definition of derivative of fx is defined as f prime x equals to limit h approaching to 0 fx plus h minus fx over h. It is also known as the first principle of differentiation. So for the table of content, we have four things here. So we have problem statement. So what is problem statement? It is what to solve. What are we going to solve? Then we have the problem solution. So how to solve it. And then we have conclusion to summarize everything. And then the fourth one would be acknowledgement, to acknowledge our lecturer and the people who help us for this assignment.
So first thing what we need to know is what is this topic about? In fundamental theorem of calculus, related rate or rate of change is one of the applications of differentiation, involving finding a rate of change of a quantity from another quantity that is already known. Snowball melting, a ladder falling, or a balloon being blown up is an example of related rates in real life. To solve this type of problems, the appropriate rate of change is determined by implicit differentiation with respect to time. For example, air is being pumped into a spherical balloon. Increasing in volume and radius occurs after the air is being pumped into the balloon. Therefore, related rates is used to relate both of the quantities. Next thing is 5 steps in answering related rates questions. In order for us to answering this kind of problems, these 5 things we need to do. So firstly, define letters to all quantities that vary with time or any others that is relevant to the problem. Such as radius, we can say dr. So secondly, identify the rate of change and interpret each rate as derivative. And thirdly, determine the formula and the equations. So formula is some kind like volume of sphere, volume of cube, cuboid, and whatsoever. And 4 is differentiate both sides of the equation with respect to time. And finally, substitute values and solve the unknown rates. So these 5 steps are we going to use in solving our problem, which is this one, the problem statement. So our problem is a ladder 20 feet long rests against a vertical wall. The bottom of the ladder slides away from the wall at a rate of 1 feet per second. How fast is the top of the ladder sliding down the wall when the bottom of the ladder is 5 feet from the wall?
Solution step 1. Let x equals to the distance from wall's base to the foot of the ladder, and let y equals to the distance of wall's base to the top of the ladder. dx over dt is equals to 1 foot per second, and when x equals to 5, dy over dt is supposed to be what? Step 2. From the diagram drawn, we know that equation is equals to x squared plus y squared equals to 20 squared. Step 3. Differentiate with respect to time. 2x dx over dt plus 2y dy over dt equals to 0. Step 4. Evaluate and solve. 2y dy over dt equals to negative 2x dx over dt. dy over dt equals negative x over y dx over dt equals to negative 5 over 19.3649 in bracket 1 equals to negative 0.2582 feet per second. Conclusion. Therefore, the top of the ladder sliding down the wall at the rate of 0.2582 feet per second, the application of differentiation is used to compute all the rate of change, and we must understand what is related rates so that we can apply it in our daily lives. Acknowledgement. First of all, we would like to convey our heartfelt thanks to our beloved lecturer, Sir Chen Chi-kyung, who always gave us support and guide us to do our assessment in purpose to produce a good outcome. He inspired us greatly to work on this assessment. His task had been done with all effort by group members, even though there are some circumstances happen. Luckily, all of the problems can be solved down, and we were able to finish it on time. We would also like to take this opportunity to thank all of those who have directly or indirectly helped us in making this assessment a successful one. We are thankful for their aspiring guidance and friendly advice during this assessment.